Okay, so I'll be explaining about depth first search. So the logic is just to go deep as possible, no, possible before backtracking. So let me give an example. So here's a graph. So um, let's say we start with A, right? So we start with A, then we visit. No, we start with A, then we visit B, then we visit D. D has no children to visit, so we backtrack to B, and then we go to E. E got no children, then we go to B, then go to A. We backtracking, and then we go to C, and then finally F. So that's the basic idea behind it.
Yeah, based on the previous example, this is a Python code demonstrating how the DFS work, and yeah, just getting right into it. So we have three arguments data, which is the graph, the starting node, and the visited list. So to track like what what node has been visited, and now we just check if node is not in the list, then we add it. So we start with the starting node A, and now we will go to B. So B is not in the list, so we add that. So from B we go to D. So we add D, and D has no children, so we backtrack to B, and now B has two children, D and E. So now we go to E, and now we backtrack again, backtrack to A, and A now will visit C, and C we will add that, and now we will visit F, which is the final node, and yeah, that's it.
So I'll be explaining about breadth first search. So it explores layer by layer. So let me give you an example on this graph here. Um, so first it will start with A. So start with A, start at A, and then it will queue. Okay, it will queue A, and any visit is empty, an empty list, because it didn't visit any node. So now it um, so now we will dqa. So we just qa, now we dqa, dq dqa, and then we visit it. So visit equal A, and now we will enqueue B and C. So now Q is B and C, and now we will dqb. Okay, we dqb, and we visit um, A and B, and our Q will now be D, and now we'll add D and E, so it will be C, D, E. Now we dqc, so dqc, and we visit A, B, C, So we did these three already, and now our Q will be D E D key DQC, right? So we have F here. Okay, so now we will DQD, and the visit list will be A, B, C, D, and our Q will be E and F. And now we DQE. Okay, we DQE. Then the visit list will now be A, B, C, D, E, and the Q will be F. And now we will DQF. We DQF, and the visit list will be A, B, C, D, E, F, and our Q will be empty list, and that's we have, and we can see that we have visit all of the nodes in the in this graph here, and that's the basic idea behind BFS, where you just visit and you queue and you DQ, and the step just keep repeating until you got no more node to queue, or no more node to DQ.
Okay, yeah, based on the previous example I showed you, this code will just demonstrate how all the dequeuing and queuing works. So we call it the depth first search, where it takes argument data and starting node, and we have to list the visited and the queue. So the queue will take the start node, initialize it with the start node, and now we will loop. So for the current node, we pop the queue. So pop A, remove A from the queue, and now we will check if current node is visited. Is not, then we add A to visited, and now we check the neighbor of A. So neighbor of A is B and C. So add B and add C. Now we will pop B. B will be our current node, and now we add B to visited. So now we look for the neighbors of B. So B and E are the neighbors, so we add them. Yep, we just added them, and now we will pop C. Yep, we pop C, and now we add C to visited. And okay, so the current node is C, right? So we look for the neighbor of C, so it's F. We add F to Q. Okay, now we will pop D. Popping D. Okay, add that to visited, and D has no neighbor. Now moving on to E. Now we pop E. E has no neighbor as well. Add E to visited, and lastly F. The same goes for F, and that's the end of the search. And yeah, that's it.